Welcome to another session of Maths Fanatics. Here we're going to prove the theorem that states that the line from the center perpendicular to the chord bisects the chord. So we have a line OM which is from the center O, and it is shown that it is perpendicular to the chord AC. So we need to show that this line is going to cut AC into two equal parts. So we have to show that AM equals to MC basically. We have to show that this side is equals to that side. Okay. So before you prove any Euclidean geometry, you need to do construction. Okay. Before you prove any Euclidean geometry theorem, you need to do construction. So I'm going to construct it. So my construction. So the construction I'm going to join the radiuses in this case. So let's use I'm going to draw my radiuses. 1, 2, and then I'm joining them. Also, there's another radius here, which needs to be joined as well. So under construction, I'm going to write join AO and OC. Everything that you write on the construction must be shown on the diagram, and everything that you draw on the diagram must be shown on the construction. And then after construction, you write RTP, which stands for required to prove. So you are telling the marker what you are required to prove. I'm required to prove that AM and MC are equal in this case. AM equals to MC, right? Then from there we come with proof now. Proof. So remember theorems, guys. You just need to memorize how to prove each and every type of theorem. This one, we're going to prove it with congruency because I have two triangles. If I can prove that the two triangles that I have here are congruent, then I can conclude that these bottom sides are also going to be the same. Right, so I'm going to say in triangle OMA and triangle O, remember, you must check the way I'm labeling it, OM, because the reason why I'm saying OM is because OM is common between this triangle and this one. So OM, also there must be OM. The order is very important. For example, here I can, if I say, okay, let's come here, OMC. Here I can say OCM or MCO, no, because I can see that AO, so AO, right, must go with OC because they're equal, these two lines. Do you see it? So AO and OC are aligned. So the sides that you see that they're equal must be aligned. By alignment, I see this. Look, from A to O, we skip one letter. Also there, we skip one letter, and they are equal, those two. From O to M is the same as O to M. Sharp. And then MA and MC are not the same, but they are also aligned because we are going to prove that MA and MC are the same. Does it make sense? So the order in which you name your triangle is important. Okay, so we can proceed now. So we're going to say OM is equals to OM. Why do we say they're equal? Because it's a common side between the two triangles. It's like a wall, you see it. So the OM is on both the triangles, so it's equal. So you're going to say common side here. You're going to say common sides. Awesome. And then we can also see that OA for this one is the same as OC for that one. And then that is a radii, right? Remember, radius of the same circle are the same. So OA is the radius, OC is the radius. So they have to be equal, right? Awesome. And then we have what? We have M1 in this triangle equals to M2 equals to 90 degrees, right? That one you can say angles on a straight line, right? Therefore, we're going to conclude now that, okay, I'm going to go right there. Therefore, triangle OMA it's congruent to triangle OMC. Your reason is right angle, right? Remember, this was hypotenuse, so hypotenuse side. Always, when you're proving congruency between right angle triangles, this is always going to be your reason. Sharp. So now you're going to say, therefore, AM equals to MC. Remember, congruency means this triangle, if I were to flip it this way, it will exactly fit on top of this one, making this part the same as that part. So then you're going to say congruent triangles, corresponding sides of congruent triangles. Then you have proven this theorem. Thank you very much, ladies and gentlemen.